Little heavy. I warn you in advance. I know when I first started my work in climate change, I attended an interfaith conference, which happens to be going on this weekend. The sixth Interfaith Climate Conference, Florida Climate Conference, is happening in St. Petersburg right now. But I'm delighted to be here with you. But I remember my first experience at that conference was life-altering, literally. Uh, I, I had, of course, heard about climate change, but I really didn't understand. And the conference opened my eyes in a way that I hope more people in the world will experience, because it's going to take all of us working together to make a difference. We're going to listen to a wonderful scientist. His name is John Rockström, and he's a Swedish scientist, internationally recognized for his work on global sustainability. He's the joint director of the Potsdam Institute for Climate Impact Research in Germany, and he is also the chief scientist of the Conservation International. He does a wonderful presentation. The first presentation that we're going to hear a part of is one that he made to a group of young leaders. There is an organization called the One Young World, and they have an annual summit where they convene the brightest young leaders from 190 plus countries and 250 plus organizations who are working to accelerate social impact. And the delegates participate in 4 transformative days of speeches, workshops, and networking. Through the summit, the delegates are counseled by influential political, business, and humanitarian leaders. And once it's over, they return, they graduate as One Young World ambassadors, returning to their workplaces and communities with the means and motivation to make a difference. Since 2010, One Young World ambassador projects have impacted the lives of over 41.56 million people. So this was an important address that he gave to an important young audience. I'm especially eager to find ways to reach young people because the burden of dealing with climate change is going to fall very heavily upon them. Let's start with John Rockström video.
Wonderful to be here with you. Let me give you a scientific update of the challenges we're facing with planet Earth. And just to summarize, in just 2 words, we are in danger. We can today unequivocally, with all the scientific evidence we have, for the first time in human history on planet Earth, conclude that we are at risk of destabilizing the beautiful blue marble, our home, planet Earth. This has never been the case before. I mean, we've been studying a lot of environmental challenges. Sustainable development has been growing over the last 30, 40 years, but now we have the evidence. We are at risk of destabilizing the very basis of life support for human development. We are at risk of kicking the planet out of its healthy state, that it's at risk of rolling away, drifting away from the basic life support that we depend on. So let me tell you this story, but also give you the final conclusion on the window of hope that we still have for a transformation, which I call for a safe landing, for a prosperous and equitable humanity on Earth. The first insight is the empirical evidence from all the observations that we have increased our pressures on planet Earth in an exponential way. You've seen the hockey sticks. It's scientifically now defined as the Anthropocene. Greek anthros for humans. We, anthros, constitute today the largest pressure on Earth, exceeding even the geological forces like solar voltaics or like solar radiative forcing, volcanic eruptions or earthquakes. we are now in the driving seat of changing the conditions on Earth. This started in the 1950s. Up until that point, we had linear change, and then we go off in this exponential rise. We can now conclude, in very simple terms, that up until roughly the 1980s, we were still a relatively small world on a big planet. You could argue that unsustainable consumption and production practices, which were still wrong already at that time, did not have invoices being sent back from the planet because there was ample ocean, ample trees, ample biodiversity, ample atmosphere, ample ice, ample atmospheric ozone stratospheric layer that protected us against pressures. From 1950s onwards, that is now finished. We've now come to a point where we're starting to hit the ceiling of what we today can call hardwired processes that regulate the functioning of the planet. Welcome to the Anthropocene. We are now a big world on a small planet, no longer this small world on this infinite planet. Insight number 2 is that the planet is a self-regulating geophysical system with all the spheres, the biosphere, the hydrosphere, the cryosphere, all the ice sheets, but also the hydrosphere, the bloodstream of the very planet, the freshwater cycle, which is behind all life, all biomass, all carbon sequestration, regulating even the stability of the climate system. Now, these spheres are so interconnected that we now understand today that the planet is a self-regulating system. And if you stress this system, when she is in a healthy state, she will buffer and dampen and do everything she biogeochemically can to remain in a stable state. We call this resilience. Resilience is the ability to take stress without falling over. And we now study what we call tipping points, being the biogeophysical systems that have multiple stable states, but push them too hard and the systems will topple over, and a healthy rainforest can become a desertified, arid steppe, or an ice sheet, a stable cooling system that reflects 90% of incoming heat back into space. It's a cooling mirror to have a beautiful Antarctic ice sheet. When that melts too far, it darkens, absorbs more heat, and self-amplifies and becomes a self-warming system. That's a tipping point. But insight number 3, dear friends, is the most deep one, and the one that really anchors why we have to become stewards of the entire planet. And that is from paleoclimatic data, from our ice core data, which now dates back 1 million years, but we actually have modeling data all the way back through the entire Quaternary, 3 million years of the journey of planet Earth. And what it shows is just astonishing. It's just beautiful and remarkable. And it goes as follows. The last 10,000 years, since we left the last ice age, is geologically defined as the Holocene. The Holocene is just a remarkable, healthy state of the planet. Can you imagine? The average temperature on Earth is 14 degrees Celsius plus minus 0.5 degrees Celsius. The planet is wobbling within this extremely narrow corridor of life. Everything we cherish, everything we love, everything we depend on, all the ecosystems, the forest, the fish in the ocean, the rainy seasons, food, everything we know, spring, summer, autumn, winter, established itself within this narrow corridor of life. It's so important that you know the story. We've been modern humans on planet Earth for roughly 250,000 years. We've lived through 2 ice ages and 2 warm interglacials. We were hunters and gatherers. We lived in caves. We had a rough time because environmental conditions were dashing up and down. In just decades, we could have plus minus 10 degrees Celsius, back and forth. We leave the last ice age some 18,000 years ago. We enter the Holocene. We barely enter it. And what do? Well, the conditions become so beautiful and so stable and so predictable on planet Earth. So we go through the most important revolution, the deepest innovation of them all through the history of modern humanity on planet Earth, the Neolithic. We domesticate animals and plants. We become farmers. We settle down in villages, and off we go in the innovation pathway that has taken us to the globalized world of today. And now we are soon 9 billion co-citizens on planet Earth, And the only ethical conclusion you can draw on this is the following. The Holocene is the only state of the planet we know for certain, dear friends, the planet on the screen here, that can support the world as we know it. We've lived outside of the Holocene as a few million people in caves as hunters and gatherers, but there's no proof anywhere that we can ethically and responsibly cater for 9 billion people in the life that we define as dignified life outside of the Holocene. So that is the scientific picture today. We're in the Anthropocene, at risk of kicking the planet out of its stability domain. Tipping points are real, self-amplifying risk, and the Holocene is a reference point for the desired planet. Put all this together and you have the mix. We have to become stewards of the entire planet.
There it is. We're stopping here because in this presentation, which is an excellent one, by the way, we never see the screen, and he starts referring to a number of graphics and things on the screen. So we're going to move to a different video by the same scientist, where we can see the graphics that he is talking about. But before we do that, I really wanted to ask you if you heard anything here that you didn't know or that you became more concerned about. Is there anyone who would like to share how this video, this statement made you feel? Yes, Carol?
Yeah.
Louis has a microphone for you.
Well, first of all, is it on?
No.
No. Yes. It is? Yes. Oh, okay. That was one heck of a history lesson. I've never heard words like Holocene before. And he was just so concise and you know, just descriptive of just what we have done and the time frame for each of you know, each of our stages of existence on this planet. That was wonderful.
Everything you're going to see.
Joan, I wonder, I was thinking if there weren't warning signs before now, during those stages that he mentioned.
I don't know the answer to that. I'm sorry he's not here. Yes. There. Yes, Robert.
There really haven't, I mean, if you think about that history of 10,000 years, the changes have been so rapid in the last, really the last 50 years, that the warning signs have really been, you know, maybe in the last 100. So it hasn't been all that visible until modern times, although these issues, you know, the last 50 years, there have been people trying to get us to wake up.
Yes, here.
One of the things that caught my eye or ear, like most people, he's only talking about humans. He's not talking about what's going to happen to the rest of the sentient beings on this planet.
You're going to hear more about that next week, as a matter of fact. So come back, and the next week's session will talk a lot about what's happening in general, not just to humans, but to the planet itself. And in fact, our leaders of next week are sitting right here. But there's so much information to share. We can only touch the tips of the information. So I do encourage you, we'll be sending out information of websites where if you want to go deeper and find out more for yourself personally, that there's a great deal of information available on the web. And I do encourage you to learn more about what's happening to our planet. The next video that we're going to show you is about the tipping points of climate change and where we stand. He talked a little bit about tipping points there, when something that is positively helping keep our climate in a healthy uh, condition tip over and begin to add to the problem. So we're going to we're going to learn a lot more about those in this video. And I warn you, it's a little scary.
What really worries us today is the ocean. The ocean absorbs 90% of the heat caused by human-induced climate change. This is well understood, but what really worries us is what you see here. This is the latest data on sea surface temperature across the ocean. What you see here is from 1980 until today, how gradually the ocean surface just gets warmer and warmer. It's actually warming all the way down to 2,000 meters depth. This is well understood in science. It's a deep concern. It's well represented in the climate models. We understand it. Then suddenly in 2023, something happens. Temperatures just go completely off the charts, 0.4 degrees Celsius outside of the warmest temperature in previous years. What's happening? We admittedly must be honest here, we do not know. El Nino is certainly partly to blame, but cannot explain it all. 2024, it just continues. What is happening? We do not know, but the candidate number one is the energy imbalance caused by us humans. In 1 year alone, the heat equivalent to 300 times global electricity use is absorbed in the Earth system. Is it what we see on the screen here, an ocean that is starting to lose resilience? An ocean that is at risk of releasing heat to the atmosphere and self-amplifying warming? We do not know, but one thing is for certain, the ocean is sounding the alarm. Reasons for concern? Yes. We are now at a point where we are forced to ask the following question. Are we at risk of pushing the planet out of the basin of attraction, the stability of the planet where we've been since we left the last ice age, the extraordinarily stable Holocene state?
There's a longer title than that. Where we stand. So here's one right. The tipping points of climate change and where we stand. The entire title.
When I started drinking warm water to help with my memory, my friends laughed at me. But when they saw how much I'd improved, they started doing it themselves. You've probably heard that as you get older, your memory will never be the same. You'll have to get used to the constant brain fog and
40 billion tons of carbon dioxide per year, giving us 5 years at current rate of emission.
I knew I was underwater. I just didn't realize I was this underwater. If you're stressed about
The Earth system scientists and climate scientists are getting seriously nervous. The planet is changing faster than we have expected. We are, despite years of raising the alarm, now seeing that the planet is actually in a situation where we underestimated risks. Abrupt changes are occurring in a way that is way beyond the realistic expectations in science. 15 years back, I introduced the planetary boundary framework, the scientific framework with the 9 Earth system processes that determines the stability, the resilience, and the life support on planet Earth. 10 years back, the world signed the Paris Climate Agreement. Almost 5 years back, we entered the decisive decade where our choices will determine the future for all generations on planet Earth. Where are we on this journey halfway into this decade? I will give you a scientific State of the Planet report, the most objective assessment that science can give today. And it starts here. We've reached 1.2 degrees Celsius of global mean surface temperature rise, the warmest temperature on Earth over the past 100,000 years. We have just scratched on 1.5 degrees Celsius as an annual mean in 2023. But what worries us most is this. We are starting to see an acceleration of warming over the past 50 years, 0.18 degrees Celsius per decade from 1970 to 2010. But then from 2014 onwards, it abruptly jumps up to 0.26 per decade. And if we follow this path, we will crash through 2 degrees Celsius within 20 years and hit 3 degrees Celsius by the year 2100, a disastrous outcome caused by us humans. But it's not only carbon dioxide. Any parameter that matters for human well-being and our economies look the same. Here you have it, linear change up until the 1950s. We go into the great acceleration, and this is what we're seeing across overconsumption of fresh water, the 6 mass extinction of species, over-eutrophying our freshwater systems with nitrogen and phosphorus, all of it undermining the stability of the planet. As if this was not enough, we are seeing that this is now causing impacts across the entire economy. We're seeing bigger and bigger invoices being sent by the Earth system onto societies across the entire world in droughts, floods, heat waves, disease patterns, human-reinforced storms, scientifically attributed to human-caused climate change. 40 degrees Celsius of life-threatening heat across all continents occurring in 2023. 52 degrees Celsius hitting the over 1,000 who lost their lives at the Hajj pilgrimage in June in Mecca. 3 times higher climate change risks now attributed to our cause of climate change. 2023 up to 12,000 deaths, $200 billion of cost just in the US, up to $100 billion. This is seriously causing economic costs. We have scientifically in the past shown that this could cost a few % of global GDP of the climate impacts caused by us. I can tell you that the latest scientific assessment is what you see on the screen here. An 18% loss of GDP by 2050 if we now follow the current path. This is equivalent to $38 trillion of loss per year in 2050. It's starting to hurt, both in human social costs and in economic costs. And this is happening at 1.2 degrees Celsius of global mean surface temperature rise, and we're following a pathway that takes us to 2.7 degrees Celsius in only 70 years. And we've had a 10,000-year period where our civilizations have developed, where we've had an enormous privilege of a planet at 14 degrees Celsius plus minus 0.5 degrees Celsius. That's the Holocene since we left the last ice age. And if you look 3 million years back, we never exceeded 2 degrees Celsius. That's the warmest temperature on Earth during the entire Quaternary. The coldest point, minus 5 degrees Celsius, ice age. I call this the corridor of life. Is it surprising that we scientists are getting really, really nervous? But it's more. It's so much more than this. The first issue is buffering capacity. The second is the risk of crossing tipping points. And both are moving in the wrong direction. Buffering capacity is the Earth system's ability to dampen shocks and stress. Like, for example, soaking up greenhouse gases in intact nature on land and in the ocean. And so far, Mother Earth has been so forgiving. Here we have the evidence. What you see here is the hockey stick of fossil fuel burning in red and deforestation in yellow. Is it this tremendous climate forcing that has caused the 1.2 degrees Celsius climate crisis so far? The answer is no. 53% of the carbon dioxide from fossil fuel burning and land system change have been soaked up by intact nature on land and in the ocean. It's only the blue sliver you see here, which remains in the atmosphere, causing the climate crisis so far. The problem is we have more and more scientific evidence of cracks in this system. Let's start on land. Land absorbs 31% of the carbon dioxide from our greenhouse gas emissions. We have more and more scientific evidence across so much research that the boreal forest in Canada or the temperate mixed forest in Germany and Russia are starting to lose their carbon uptake capacity. Did you know that the latest science shows that the part of the Amazon rainforest, planet Earth's richest biome on terrestrial land, has already tipped over and is no longer a carbon sink? It is today a carbon source. It's no longer helping us. But as if that was not enough, what really worries us today is the ocean. The ocean absorbs 90% of the heat caused by human-induced climate change. This is well understood, but what really worries us is what you see here. This is the latest data on sea surface temperature across the ocean. What you see here is from 1980 until today, how gradually the ocean surface just gets warmer and warmer. It's actually warming all the way down to 2,000 meters depth. This is well understood in science. It's a deep concern. It's well represented in the climate models. We understand it. Then suddenly in 2023, something happens. Temperatures just go completely off the charts, 0.4 degrees Celsius outside of the warmest temperature in previous years. What's happening? We admittedly must be honest here. We do not know. El Niño is certainly partly to blame, but cannot explain it all. 2024, it just continues. What is happening? We do not know, but the candidate number one is the energy imbalance caused by us humans. In 1 year alone, the heat equivalent to 300 times global electricity use is absorbed in the Earth system. Is it what we see on the screen here, an ocean that is starting to lose resilience? An ocean that is at risk of releasing heat to the atmosphere and self-amplifying warming? We do not know, but one thing is for certain, the ocean is sounding the alarm. Reasons for concern? Yes. We are now at a point where we are forced to ask the following question. Are we at risk of pushing the planet out of the basin of attraction, the stability of the planet where we've been since we left the last ice age, the extraordinarily stable Holocene state? And if we pushed ourselves outside, drifting away unstoppably towards a hothouse Earth where we get self-amplified warming and losing life support on Earth. What could take us there? Well, we know it. It is if we cross tipping points. Big systems like the Greenland ice sheet, the overturning of heat in the North Atlantic, the coral reef systems, the Amazon rainforest, are tipping element systems. Push them too far and they will flip over from a desired state that helps us to a state that will self-amplify in the wrong direction, going from cooling and dampening to self-amplifying and warming. A rainforest tips over to a savanna state. Now, we have now mapped the 16 tipping element systems that are now scientifically cataloged that regulate the climate system. These 16, and you see the 5 in the ground zero on planet Earth in the Arctic, are connected via cascades through the ocean, particularly via the AMOC, the Atlantic overturning of heat in the ocean, all the way down to Antarctica. These are big biophysical systems that we all depend on, global commons for the stability of the planet. The question is, at what temperatures are they at risk of tipping from helping us to becoming self-amplifying foes? Well, for the first time, we have an attempt to answer that question. What you see here are the 16 tipping element systems on the y-axis, and in red you see the uncertainty range, the best estimates in science. Darker the red, the higher the risk of tipping is the temperature levels at which they're likely to cross the thresholds. The average temperature at which they are likely to tip is the yellow circle lines you see here. What this tells us is the following. 5 of these 16 are likely to cross their tipping points already at 1.5 degrees Celsius. The Greenland ice sheet, the West Antarctic ice sheet, abrupt thawing of permafrost, losing all tropical coral reef systems, and collapse of the Barents Sea ice. Just the 2 ice sheets hold 10-meter sea level rise, which would be unstoppable on the long term. Now sure, there's scientific uncertainty here, as you see from this graph, but there's one red thread in science for humanity and the scientific message, and it's this: the more we understand of the Earth system, the higher is the risk. And here is the proof. This is 5 IPCC assessments, the Intergovernmental Panel on Climate Change, 30 years of scientific advancements. Here again, you see risk assessment, darker the red, higher the likelihood of causing irreversible change in the climate system. 30 years back, the risk was put at 5 degrees Celsius of tipping, and coming down to current state of science, the risk is set at 1.5 to 2 degrees Celsius. We are in the midst of a danger zone today. But it can be even worse than that. Let's go to the Amazon basin. Again, the richest terrestrial ecosystem on land. Climate science estimates the risk of the Amazon rainforest tipping over irreversibly to a savanna at 3 to 5 degrees of global mean surface temperature rise. A really high temperature, unlikely even to be met over the next 70 years. But if we lose forest cover, the risk is that the system can tip already at 1.5 to 2 degrees Celsius if we lose more than 20 to 25% of forest cover. So that's a very dangerous combination. Where are we today? We are at 1.2 degrees Celsius global mean surface temperature rise and 17% of deforestation. We are very close to a tipping point in the Amazon rainforest. Very close. What shall we do to avoid these unmanageable outcomes? Well, the IPCC is clear on the pathway. To stay under 1.5 degrees Celsius, to avoid crossing tipping points, we need to operate, to navigate within the global carbon budget that gives us a chance of holding 1.5. What remains for us is only 200 billion tons of carbon dioxide that we can continue emitting to have a 50% chance of holding 1.5. We emit today 40 billion tons of carbon dioxide per year, giving us 5 years at current rate of emission before we've consumed the budget. We are seriously running out of time. And the pathway for a safe landing is also well studied and understood. You have it here. Bend the curve of emissions immediately and follow a path where we reduce emissions by at least 7% per year for a safe landing and a net zero world economy by 2050. But it's more than that. We also know that even if we succeed with this, we have already loaded the atmosphere with so much greenhouse gases, with so much climate forcing, that we inevitably face a period of overshoot. We must now be prepared for a very likely breaching of the 1.5 degrees Celsius planetary boundary on climate somewhere between 2030 and 2035, in 5 to 10 years' time, and then have at best a 30, 40-year period of overshoot before we can come back to 1.5 by the end of this century. We would exceed with 0.1 to 0.3 degrees Celsius the 1.5 limit, meaning up to 1.8 degrees Celsius. What does this tell us? Well, I can tell you there are 2 main messages. Message 1, buckle up. We know for certain, 100% certainty, that this means more droughts, more floods, more heat waves, more human-reinforced storms, more disease during one generation's time. 2023, the warmest year on record, will be looked back upon as a mild year. Message 2, why would the planet come back to 1.5 after overshoot? Well, the answer is very simple. The health of the planet must be kept intact. We must continue having a planet that can absorb 50% of the carbon dioxide. We must have a planet that crosses no tipping points. We must have a planet that remains healthy and keeping heat intact in the ocean. That is why we need planetary boundaries. The planetary boundary framework that defines the 9 Earth system processes that regulates the stability and resilience of the entire planet. Climate, biodiversity, nitrogen, phosphorus, land, fresh water, air pollutants, and chemicals. That is the challenge. To summarize that, there is no 1.5 degrees Celsius delivery on the Paris Agreement by only phasing out fossil fuels. We also need to come back into the safe operating space of the nature-based biodiversity, all the planetary boundaries of nature. This means the science is clear. The window is rapidly closing. But there is still some light in the window. We actually have evidence that we've reached a pivotal point, not only in terms of risk, but also in terms of opportunity to transform the world towards a safe and just future for humanity. Linear change is no longer an option. The only option is exponential change. We know that the only currency that matters is speed and scale. We also need to become stewards of the entire planet. We need to now recognize from local to global level that we're all so intertwined that we must govern the entire planet. I know that is very daunting, but what choice do we have when on the line is the future of our children on planet Earth? And we have the solutions. We know that solving the planet crisis is not utopia. It's not fantasy. We have the solutions for a secure, stable future for humanity. What are those transformations? Well, we know them. It's a rapid transition away from fossil fuels. It is a transition towards circular business models. It is transitioning towards healthy diets from sustainable food systems. And it's not only halting loss of nature, it's also scaling the regeneration and restoration of marine systems, soils, forests, and wetlands. We have solutions for all of these. Just take green energy, which today is cheaper than fossil fuel-based energy. It's our choice that we're facing today. Now, I was nervous already in 2020 when we entered this decisive decade and had to cut global emissions by half by 2030. Halfway into this decade, the road is steeper than ever. It's steeper than ever. This is what really, really concerns us, that we have a situation where we now need to move so fast. And I've been standing on stages like this so many times, sharing the dire scientific diagnostic. But still, I just told you that I do conclude that there is still some window open. There is a light in the tunnel. And you may ask, what is it that makes me able to continue to be a realistic optimist in this situation? The most dire situation, I must admit, in my whole professional life. Well, actually, I promise this is an honest statement. There are so many positive items as well. The most important one in my mind is that we have ample evidence that citizens across the world, a majority of them, care about nature and climate. They trust climate science, they're concerned about climate change, and they want solutions. And the second key factor is that we have so much evidence today that the solutions are not only available, but if we implement them, we get a more healthy, stable, secure future with the jobs and the economies that can compete and provide livelihoods into the future. This means, dear friends, that solving the planetary crisis is not only necessary, it is possible, and we all win if we succeed. Thank you very much.
A lot to absorb there, but I would like to hear some of your reactions to what you've just learned. Linda? Lewis?
I think it was a couple of weeks ago that President Trump said we need to drill. We need to bring up oil. And he will not understand or care to try to understand any of this. And he's leading what used to be one of the more powerful economic systems in the world. I don't trust him. He's got, 3 years and 12 months? I don't know. I'm so discouraged.
Yes, anybody else want to comment? Yes, Michael?
The man must be a Unitarian. He lives in a fantasy world. As she just said, it's not only going up, it's going up steeper all the time. Now, drill baby drill really doesn't have anything to do with it. It's how much we use. It doesn't matter how much we drill. The drill baby drill is just going to bring the cost lower, so we use more. But we see that. I mean, is there any chance of turning that around? Not that I can see.
Other comments? I don't think any of us are people who like to self-deceive. I think we all like to face the world the way it is and say, okay, what do we need to do to change it? And we are now facing, Linda, a very challenging reality. with our president and what he's trying to do, what he's not doing, which only makes our challenges stronger. As frightening as that may be, to consider the alternative is for me a heck of a lot scarier than doing something. I can't imagine doing nothing after listening to that video. I just can't imagine it. The consequences are too dire. I have 3 great-grandchildren. They're adorable. They're ages 7, 5, and 3. And my focus is not on what's left of my life, but what's ahead for theirs. And I think that if all of us can start thinking about our legacies to the future generations, and if we can all be inspired by the great work that is going on in the world. There's great work, and you're going to hear a lot about it in our workshops. Unfortunately, we have to tell you about the problems first. But there are a lot of wonderful things being done, a lot of progress being made, a lot of solutions being implemented. Unfortunately, some of them are being implemented in places other than the United States, but there's a lot happening. So it is a huge challenge for all of us, but it's not hopeless. And if you give in to hopelessness, you create the reality that we want to avoid. So we can't afford to become hopeless. And I encourage all of you to learn more. There's so much information. We're going to be sending out websites that you might want to look at. We send out information to you. Learn more because it actually will make you feel stronger, not more threatened, but more capable of handling the reality of our situation. And thank you so much for coming. I hope that we see all of you again next week. Bob and Ariel are going to be leading the session next week, and they have a rich source of information to share with us, and I'm looking forward to it. Thank you again.